So in this video, I want to talk to you a little bit about how we can sketch graphs of logs using the stuff we've learned earlier in the semester about transformations. So our prompt that we're going to be moving towards is sketching the graph of this function, f of x equals -2 natural log x plus 1 plus 3. Now the way I want to start is I'd like to think about base functions. And I've plotted using Desmos two different functions. The red function is log base 10, so we don't write the 10. And then the blue function is ln, or natural log, and that's base e. For the problem that we're being asked to do, you're seeing the natural log over here. So this is going to be the base function that I care about. I wanted to just put both on the same graph quickly to show you, because I think there also are some homework questions that ask you to graph transformations of log base 10. And so I just wanted you to get a sense of what that looked like. So what this is showing me is the graph of natural log of x. The things that are pretty important about it are it always has an x-intercept that's at 1, 0. There's a vertical asymptote that's the y-axis, and then it grows kind of steadily like that. So that is my base function. Now, it's also important to note that the domain of a log, any log, is 0 to infinity, and 0 is not included because of that vertical asymptote that we have. Another way to think about it is I can't raise a base to a power and get back the number 0. So that's the other reason that it is not defined. So this is the base function, and then what I want to do is I'd like to look at the function that I have been given. I'll just leave that alone. And think a little about the transformations, just like we did earlier in the class. So remember that if you're seeing a number added inside a function, this is shifting my function horizontally, and because it's a plus, I know it moves it left 1 unit. The 2 multiplying out in front is a vertical stretch by a factor of 2. So I'll put vertical stretch by 2. The minus is going to be a reflection, and the reflection is happening across the x-axis. And then when all that is done, the last thing that needs to happen is we need to shift vertically or shift up by 3. So these are the transformations that are taking place of this base function that we have. So what we should do is move through them kind of one at a time. So I'm going to build this function that we have. Let's write it down. So I have this. Okay, so the way we want to think about our transformations are we have the graph of natural log of x, and it's very helpful to track maybe just one point. And the next thing I want to do is shift it left by 1. And the reason tracking this point is kind of helpful, maybe I'll use a color so you can see it a little better. If that point moves left 1 unit, suddenly it's right here. And this point is now 0, 0. Now the overall shape of the function's graph is no different. And in fact, if you feel motivated to do so, this vertical asymptote is now shifted where instead of at 0, now it's at -1. Okay, so I took care of the left-right. Now, why don't we deal with the vertical stretching? So I have 2 ln x plus 1. Now, I'm not drawing this super carefully, so I can just qualitatively capture that. My 0 is still the same. My asymptote is still the same. But basically what's happening is my function is going to be getting steeper. So instead of growing really shallowly, maybe it's looking more like that. Again, if you do this on Desmos, it'll do axes for you and it'll be very, very clear. For sketching, it's okay for it to just be qualitative. So the next thing I want to deal with is this minus sign. So I'm going to sketch -2 ln of x plus 1. And the sketch is going to be exactly like this one. The only thing that's different is it needs to be reflected. So I'm going to look at the function that's in the upper right, and I'm going to reflect it. And so what is going to happen is we'll have this vertical asymptote hanging out here, and then the red point has not moved because it's a 0, so it's there. And then the shape of the function now is going to be like that. So the relationship between this and this is just that the x-axis acted as a mirror. Now, the very last thing that we need to do is we need to shift this up by 3 units. So you might ask yourself, where does that red point go? It was at 0, 0. Now the red point, if I move it up 3 units, will be at 0, 3. And the asymptote is still at the same value. And then the shape is the same, and ultimately this is still, going forever that direction. So this would be the final graph. And we could check that with Desmos. Now, there probably are some questions as well about the domain and the range. So the domain of the original natural log function, we made the observation that you could really only give it positive numbers. From looking at this graph, I can make the comment that the domain is, it's not allowed to be -1. There's a vertical asymptote there, but it can get really, really close to it. So -1 to infinity. The range is all real numbers. The function, goes to positive infinity and goes to negative infinity in terms of the y's. So there was a second question that I would also like to discuss, and that was sketch 3 log of -x through transformations as well. Now, from the first slide I did, the base function is log base 10 of x, which we just write log of x. And the Desmos graph is on the first slide if you would like it to look a little bit fancier. But the overall shape, it's just like the natural log. It's just not going to grow as steeply. So we have the following. So let's think a little bit. I guess there are probably some questions about the domain and the range of this base function. Well, just like for ln, the domain is the numbers from 0 to infinity, not including 0. The range is all real numbers. And then I think we also need to identify the transformations that are taking place. So this negative, it's happening inside the log. And what this is doing is it's reflecting the graph across the y-axis. And then the multiplication by 3 is a vertical stretch. And that's by a factor of 3. So this one actually has fewer steps. The first thing we'll do, we have log x there, so log of -x. It's going to treat this time the y-axis like a mirror, and I'm going to reflect the red points. So instead of being at +1, now it's at -1, 0. And the shape of the function is just as if I've held up a mirror to it. And the vertical asymptote is exactly the same. If it helps you to see it, it's down here and it's down here. So that's the first piece. The next piece is I want to vertically stretch this by a factor of 3. Again, if you do this on Desmos where the graph is, the axes are labeled, you can really see the difference. Here, I'm just drawing it qualitatively. The idea is it should be at higher, 3 times as high the y values, so kind of more like that shape. And this would be the answer. So I think there are probably some questions about the domain of this function. Well, this time the function is over on the left of the plane, so -infinity to 0, and it's not actually going to include 0 because that was the vertical asymptote. And then the range, just like before, we're getting back all real numbers. So the way this relates to what you've learned earlier in the semester is we've had things like sketch, how about like 2x plus 1 quantity squared minus 3, or plus 3 would negate this. What we talked about was finding this base function of a parabola. And then we went through and we discussed, okay, well, this shifts left by 1. This is vertical stretch by a factor of 2, reflection across the x-axis, and then vertical shift. And the transformations in this are actually exactly the same as the transformations we did for the log. And so what is different is just the base function. So what we did for our first problem is we sketched, instead of x squared, this. And so The moves end up being exactly the same, but what we needed to kind of update for this section is the base function, natural log, and it looks like this. So once you know the base function, you can reuse all of the stuff that you learned earlier in the semester.